Inserting alien electronics into the electronic voting machine in a classic man-in-the-middle attack allows would-be vote tamperers to control the touchscreen, but also the information being sent to the voting machine's computer. The cost of parts for this attack is $10 to $26 in retail quantities, much cheaper in volume. This attack does not require understanding what the computer or microprocessor in the voting machine is doing. This attack highlights the importance of checking inside electronic voting machines for evidence of alien electronics or other evidence of tampering. Hello, I'm Roger Johnston.
And I'm John Warner.
We're with the Vulnerability Assessment Team at Argonne National Laboratory. This video demonstrates some potential man-in-the-middle electronic attacks on the Diebold TS electronic voting machine. Now, we've previously demonstrated similar kind of man-in-the-middle attacks on a Sequoia Advantage AVC voting machine. And indeed, we believe these man-in-the-middle attacks are potentially possible on a wide variety of electronic voting machines.
We aren't trying to pick specifically on Diebold or Advantage AVC Plus. These just happen to be the voting machines that we have access to. The attacks we've implemented in these machines, we believe, would work on a large variety of voting machines. And the way it basically works, in essence, is you have the brains of the machine and a user interface. Now, the user interface has to communicate with the brains, and that communication channel is where the man-in-the-middle attack goes. This is a fundamentally very powerful attack, and we believe that voting officials should become aware of this and stop focusing strictly on cyber. There's a very large physical protection component of the voting machine that needs to be addressed. For voting officials and manufacturers that are interested in more information on physically protecting their voting machines, please contact us, the Vulnerability Assessment Team at Argonne National Laboratory.
Our concern has been that much of the focus on the security of electronic voting machines has been done by computer scientists and cyber hackers. And while we agree that many of these attacks that have been demonstrated are certainly viable attacks, in some cases they require a fair amount of sophistication on the part of the attacker. The attacks that we're going to demonstrate in this video and that we've previously shown on the Sequoia Advantage AVC machine really doesn't require much understanding of what's going on in the microprocessor. Relatively little reverse engineering is necessary, and one certainly doesn't have to, for example, reverse engineer the microprocessor code. Our concern is much of the countermeasures that people are attempting to implement are based on the concept of cyber attacks. And certainly cybersecurity is of enormous concern in electronic voting machines. But we think the physical and electronic type of intrusion attacks we're going to demonstrate in this video are also of great concern. And it's very important to be checking electronic voting machines for the presence of alien electronics, particularly man-in-the-middle or backdoor attacks. And also it's very important to do a good job with tamper detection that would detect the evidence of physical or electronic intrusion. The problem is that the way tamper-indicating seals are typically used in elections, in our view, is simply inadequate to reliably detect physical or electronic intrusion. Certainly anyone interested in some suggestions for how to do a better job with using tamper-indicating seals should feel free to contact us for additional information.
Because of the limited time and funding for this project, we didn't have a lot of time to make a really nice video. However, we believe that the video we did make will demonstrate comprehensively that we were able to take control of the voting machine.
So what we're going to do is essentially show a man-in-the-middle attack where we essentially control the touch screen. This type of attack has implications for other kinds of applications, not necessarily involving voting, where there is input by a user using a touch screen. We're going to control the information flow, in this case into the computer. In the case of the Advantage AVC machine, we also controlled it bidirectionally. That is, our man-in-the-middle attack essentially interfered or tampered with the data being transmitted both between the user and the microprocessor, and between the microprocessor and the user. The latter is a more powerful attack where you do it bidirectionally. But as I think this video demonstrates, even if you can only do it unidirectionally, that's a pretty serious attack on the reliability of the voting occurring in the voting machine.
The total cost of the parts for the attack that you're going to see was $10.50 in retail quantities. If you want to use the RF remote control to start and stop the attacks, that's another $15. So the total cost would be $26. Now it's important to note that you don't need the remote control. We can start or stop the attack based on time or any one of any other types of triggers. The level of sophistication it took to develop the circuit board was that of basically a 8th grade science shop. Anybody with an electronics workbench could put this together.
We're going to demonstrate really 3 kinds of attacks or demonstrations that we really do control the touchscreen. In the first one, we're going to basically remotely push buttons. So you'll be able to see that while no one's actually operating a touchscreen, from a distance we can cause certain buttons to be pressed. Secondly, we're going to show the ability to allow the voter to input certain buttons, and then we will intercept that and instead introduce our own sequence of button pushes. And finally, we're going to show something that's probably the most relevant attack for vote tampering. That's where we go ahead and let the voter push a number of different buttons. But when he or she gets ready to register those votes to push the Vote Now button, we will simply intercept that attempt to push the Vote Now button, change a few of the votes, and then go ahead and send the Vote Now so that the votes are actually registered. And in order to do this, we blank the screen temporarily so that the voter doesn't see that there's some revoting going on prior to the final registration of the votes. Certainly the microprocessor can keep track of who the voters are voting for, and we don't have to tamper with those votes if the voter is voting for the candidate that we, the bad guys, want to win the election. Also, it's important to recognize that we don't necessarily have to change all the votes in the entire election. We may be interested only in 1 or 2 particular positions that candidates are running for. So the actual fiddling with the actual votes chosen may be relatively modest. On the other hand, it's entirely possible to go and change all the votes that any one voter is voting for. Now these attacks, these insertions of the alien electronics that allow us to do the man-in-the-middle attack, which really is a microprocessor in the middle attack, but it's traditionally called a man-in-the-middle. This, in theory, could be done during election, but that requires a high probability of being detected. The more realistic way to insert these alien electronics is to do it while the voting machines are waiting in the polling place a week or 2 prior to the election. Often the polling places are an elementary school or a church basement, or some place that doesn't really have a great deal of security. Or the voting machines can be tampered while they're in transit to the polling place, or while they're in storage at the warehouse between elections.
One really nice thing about this attack, the man-in-the-middle, is that there's no soldering or destruction of the circuit board of any kind. You can remove this attack and leave no forensics evidence that we've been there.
Unfortunately, we didn't have the software to run an actual election, so you're going to see a demonstration of how we control the touchscreen, and you kind of have to use your imagination to see how that could be applied to actually tampering with the voting.
The first one, second one, and third one.
In this next scene, think of the pressing of 4 numbered keys as the voters selecting 4 candidates. Think of the OK button as the Vote Now button that would register the votes. When this button is pushed, the alien microprocessor blocks the Vote Now button, very briefly blanks the screen so the voter is unaware of what is happening, quickly votes for 4 different candidates, then executes the Vote Now function to record the wrong votes.
Entering the numbers 4, 5, 6, and 7 generate an incorrect pin code. This attack, what we're going to do is we're going to enter the same 4, 5, 6, and 7. When I hit the OK button, the circuitry inside the machine will clear the incorrect pin numbers, insert the correct pin numbers, and then forward to the supervisory menu screen.
Let's see that again and note that we blank the screen out. This is important because when the voter hits the Vote Now button to register his votes, we can blank the screen and then go back and vote differently, and the voter will be unaware that this has happened. The clicking sound with additional voting can be toggled on and off remotely, so there will be no indication to the voter that additional voting is taking place. We could certainly miniaturize the alien electronics we've inserted inside the voting machine, making it much harder to detect, but since almost no one opens up voting machines to check for alien electronics in the interior, this is probably unnecessary. Note that there is no soldering or damage to the printed circuit board, so that when we're done with the attack, we can simply remove the alien electronics, and there's no evidence whatsoever that tampering ever occurred. While this is not uncommon, it should not be this easy to gain access to the interior electronics of a voting machine. The attackers need merely to cut out the connector, allowing access to the interior of the electronics. This can then be repaired cosmetically, but because almost no one checks this connector, it probably isn't even necessary to do that.
The voting module can be removed from the base simply by sliding. This gives you access to the printer pins, therefore you do not need to pick the lock in order to gain access to the printer.
This is a test printout from the printer and demonstrates that we can control what is being printed.